Leave a bicycle out in the rain for a few weeks, and the iron frame will start to flake and turn a dull reddish brown. But leave a stainless steel spoon sitting in a sink full of water for days, and it remains perfectly shiny. Both are made primarily of iron, and both are exposed to the exact same elements. So why does one deteriorate while the other survives? Oxidation occurs when pure elements combine with oxygen molecules to form oxides. Metal oxides dissolve in water to form a base, turning red litmus blue. Non-metal oxides act oppositely, forming acidic solutions that turn blue litmus red. Observing these reactions in a beaker is one thing, but when the structural metals we use to build our cities, bridges, and vehicles interact with the oxygen in our atmosphere, these exact same chemical processes actively threaten the strength and safety of our built environment. This gradual chemical degradation of a metal surface is called corrosion. When we zoom in on that neglected bicycle frame, we are looking at a very specific type of corrosion, the rusting of iron. Rust doesn't just happen randomly. It requires a strict chemical recipe to occur. To identify the exact ingredients, scientists use a comparative test with 3 identical iron nails in 3 different environments. This diagram shows 3 test scenarios. In tube A, the iron nail is exposed to air, but we added silica gel to the bottom. It absorbs moisture, creating completely dry air. After several days, the nail remains shiny, 0 rust. In tube B, the nail is completely submerged in water. The water was boiled to remove dissolved gases, and a layer of oil was poured on top to seal it. Without dissolved oxygen in the water, there is 0 rust. Finally, in tube C, the nail is placed in ordinary tap water and left entirely open to the air. Here, both oxygen and moisture are present. The chemical reaction triggers, and a brown crust of iron oxide forms. The real danger of iron oxide is its physical structure. Unlike some metal oxides that form a hard, protective shell, rust is porous and flaky. It continually peels away from the surface, dropping off and exposing a fresh layer of vulnerable iron underneath to the elements, continuing the cycle until the metal is eaten away. Because rust strictly requires the presence of both oxygen and water simultaneously, the solution to preventing it is straightforward. You systematically break the recipe. You engineer a way to keep those 2 ingredients away from the iron. The most common way to break the rust recipe is to build a physical barrier. If ambient air and water literally cannot touch the surface of the metal, the chemical reaction cannot start. This is why we paint expansive iron bridges, ships, and gates. The paint creates an impermeable seal over the iron. For the moving parts inside a car engine or a bicycle chain, engineers use heavy oils and greases to achieve the exact same barrier effect. This animation illustrates another method called galvanization. People often mistake galvanized steel for a mixed metal, but it is actually a sacrificial metal armor. A thin, separate layer of zinc is applied directly over the top of the iron to shield it from the atmosphere. Chromium plating works on this exact same principle. A thin layer of chromium is deposited over iron or steel to create a highly reflective protective coating. It's the reason the taps in your bathroom shine without rusting, despite being in the most humid room in the house. But surface coatings and metal armors have a fatal flaw. They are only as good as their weakest point. A single deep scratch from a rock or a tool can breach the barrier, letting oxygen and water slip in and start rusting the iron from underneath the paint. To truly protect a metal, you need an internal chemical solution. This animated model shows what happens when you create an alloy. An alloy is a homogeneous mixture of 2 or more metals, or a metal and a nonmetal. By physically mixing the elements together, you alter the material from the inside out. This is the secret to our surviving spoon. The spoon is made of stainless steel, an alloy created by chemically combining iron with carbon, chromium, and nickel. Instead of relying on a painted barrier on the outside, the chromium in the alloy reacts with oxygen to build its own microscopic, self-healing shield right on the surface. If it gets scratched, the shield instantly reforms. Whether it's a painted fence, a galvanized bucket, or a stainless steel spoon, the survival of these everyday objects comes down to chemistry. By understanding exactly how elements interact with our atmosphere, human engineering systematically outsmarts natural degradation.